How can we run and test the image thresholding example in the Vitis emulators? This lecture will address this question. Run the Vitis software and create a new project. Choose ZCU102 platform as a target FPGA platform. Choose a project name, such as image_thresholding-ZCU102-Vitis. Fill in the 3 empty fields in the domain page. Create a kernel source file under the kernel project with the name of image_thresholding-kernel.cpp. Copy the kernel code into the created file. You can find the source codes in the resources folder attached to this lecture. Then, create a host source file under the host project. Let's go through the host code. First, we should define a few macros before including the OpenCL header file, telling the compiler to use OpenCL 1.2. As we are going to use OpenCV functions for image manipulations, we should include a few related header files. Now we can start coding the main function. 2 variables of the OpenCV math type are defined to hold the input image and the corresponding grayscale image. Then we can read the source image file. You can get the image file name as the input arguments. However, here I have assumed a hard-coded image file name. Then we can calculate the image size in bytes. As our hardware accelerator accepts a grayscale image, we can use the OpenCV CVColor function to convert the input image into its corresponding grayscale image. Now we define 2 math variables to hold the output images generated by the hardware accelerator and the software golden. We use the clone member function to make the output image sizes as the input image sizes. Also, I have considered 2 values for the threshold value and the max binary value variables required by the thresholding algorithm. Now we can detect the OpenCL platform and the corresponding device. Then we should define a context and the related command queue. Then we should load the kernel binary file and define the kernel in the program object. As the kernel has an input and an output array arguments, we define 2 OpenCL buffers corresponding to these arguments. After that, we can set the kernel arguments. Then we get the host side buffer pointers and copy the input image to the input buffer. Also, we set the data pointer of the output image to the output buffer. Now we can invoke the kernel accelerator by pushing 3 OpenCL commands into the command queue. Finally, we should wait for the results using the finish command. Now we can save the generated image into a file using the OpenCV image write function. Then we use the OpenCV threshold function as the golden model. We can save the generated image into a file. Finally, we can compare the hardware accelerator output with the golden model and report any possible errors. After describing the kernel and host codes, we should introduce the kernel function to the project. Go to the kernel project file and press on the Add Hardware icon, and add the image_thresholding_kernel function as a hardware module. As we are using the OpenCV library, we should tell the compiler to link the required libraries. Right-click on the host program and select the Project Properties option. Then, under the Setting Libraries, add 4 libraries. Now we should define the input data to the host program. For this purpose, we should define a folder with the name of data under the host project. Vitis automatically adds the data folder and its contents into the generated SD card files, and we can have access to them in the emulator. Define the data folder and copy an image file into the folder. In our example, the input image file should be test_image.jpg. Now we are ready to compile the code. After finishing the compilation process successfully, run the project for the software emulator. After booting the Linux in the emulator, you should see the By Thresholding Image message in the console view. This completes the software emulation. But if you are curious to see the generated file, first run the sync command in the emulator to write all the Linux buffer's data in the virtual SD card. Then go to the image_thresholding-ZCU102-Vitis_system folder in your project location. Then go to the emulation-software/package. You should see the sd_card.image file, which contains the virtual SD card used in the Vitis software emulator. Double-click on the file to mount that into your host machine. Then open the folder and display the generated images by double-clicking on the corresponding files. Similarly, we can perform the hardware emulation. First, Change the active build configuration to emulation hardware. As we have changed the build configuration, we should add the OpenCV libraries again to the compiler options. And after that, we can build the project. After finishing the build process successfully, run the project as the hardware emulator. Select the Launch Emulator in GUI mode to display waveforms in the Launch on Emulator dialog box, and press Start Emulator and run. You should see the Linux is booting in the emulator. The Vivado waveform viewer will be opened automatically. The emulation process pauses until you click on the Run All icon on the Vivado toolbar. Then, the hardware emulation resumes. As our image is fairly large, it takes a while to finish the process. And you will see the By-thresholding image message in the console view. Now, go to the Vivado waveform and inspect the data transaction between host and kernel. In the next course of this series, I will explain the concepts behind these waveforms and how to use them for kernel optimization. Now that we have performed the image thresholding, we should run the application on the actual hardware. The next lecture will address this task. These are our takeaway messages. We can use OpenCV libraries to work with images in Vitas. It is better to choose a small data in the hardware emulator. Now the quiz question. How can we add software libraries such as OpenCV to a Vitas project?